Hello everyone, I'm Jonathan Brendefur from the Developing Mathematical Thinking Institute, and I'm going to give an overview on measurement. Measurement is one of those critical areas, like geometry, that pervade mathematics, but sometimes we underutilize it. We put measurement at the end of our curriculum. So I want to talk about how important it is, why it's so critical, and how we can use it to propel kids to really understand a deeper part of mathematics, including algebraic reasoning, proportional thinking, multiplicative thinking, and all other number issues. So measurement is about comparing different things and about ordering different things. And so what are those things? Well, we talk about different attributes. So I'll give a quick example. We could have two rocks. You could say, compare these rocks. Well, it could be the weight. That could be the attribute. Which one is heavier? Which one is lighter? You could also compare the height. You could also compare the circumference. So you have to name what you're going to be focusing on. And then you could also order if you had 3 rocks or 4 rocks, depending on what that attribute is. So that's the beginning thinking about measurement. Another thing, big idea, is qualitative and quantitative. So first of all, we want to be able to qualitatively describe different types of measurement. So this person is taller, this person is shorter. As I was saying, the rocks are heavier, lighter. This line is longer, this line is shorter. It's hotter, it's colder. So we have all these different comparisons that we can make. And then we can quantify it. This person is 62 inches tall. This person is 5 inches taller than this other person. So qualitative and quantitative are both very important. Now, I also want to talk about 4 structural components of measurement, 4 key ideas. The first one is the units. What units are we referring to? And we have another video that talks about how we look at linear, area, and volume differently. But it could be, yes, linear. So we have a line. We have area, square units. We have cubic centimeters, cubic inches, a cubic measurement. We also have time. We have temperature. We have weight, capacity. So lots of different types. We talk about what unit we're referring to. And then an important idea is, how do we iterate? How do we copy that unit again and again with no gaps and overlaps? That becomes one of the misconceptions that kids have. And also, how do we partition? How do we take something and then we partition, like a line, we partition to smaller equivalent units? So that becomes structure. So that starts from preschool and goes all the way through high school. Another important idea is 0. So if I take a linear measurement here and I make these marks, I just have some non-standard unit. One idea is that where do we start with 0? This could be 0. And then along with these units, 0, instead of just counting, so this becomes another misconception. Are kids counting the dots? Because that's what they're used to counting, like cubes or chips, things like that. But this is an accumulation of distance. So here we go from 0 to 1 to 2 to 3. So being able to label that becomes really important. Having all kids practice with steps. I'm at 0, and then when I get to 1 step, that's 1. So instead of just pointing, we're actually accumulating distance. So 0 becomes another one of those structural components. Another big idea is transitivity. So transitivity is using a given measure to really understand another measure. One way of looking at it is A is equal to B and B is equal to C. Then we know that A is also equal to C. So even though we didn't compare A and C, we know these other quantities here. So it's important for kids to look at and see, yeah, those 2 measures are about the same, whether they are linear, area, weight, whatever it is. It comes in a little later when we start doing, we like to call these quick draws. We have some different tasks in there. And if I know that this length here is 2, then what other lengths around there are also 2? I do this fast, but thinking that over here, that's going to be that same measure. And if this is 3, then this length over here is 3 as well. And this one, we're going to say is 2, being able to see that same distance there. Then what would be this measure up here? If this is 1 and this is 1, 1, 2, and 1, that makes 4. We could have a length of 4. It's not to scale, but you get the idea. So that's an important idea that starts in the early grades, and by 4th grade, that's a huge idea. The fourth big idea is conservation. So a lot of people remember the Piagetian task where you fill one tall glass with water. You take that same amount of water and you put it into another glass that's shorter, wider, and you ask kids, is it the same amount of water? And a lot of them are saying, no, it's not. So that's conservation. And it is also things where if I have 4 here, is that the same as, question mark, is that the same as this amount here? So looking at it geometrically. Or this we might see as 2 plus 2, is that also equal to 1 plus 1 plus 1 plus 1? So both are 4 equals 4. But it's the idea that you can visually see it, numerically see it, so you can compose and decompose geometric amounts and numerical amounts, and that helps you really understand number and the idea of measurement. So hopefully that gives you a start on measurement. Doesn't matter what grade you're teaching. Stay focused on comparing and ordering. Have kids talk about the qualitative differences, the quantitative differences, and then also focus on these 4 structural components at any given moment while you're doing measurement types tasks. So hopefully that's helpful. Visit our website, www.dmtinstitute.com.